Good morning, students. Welcome to 9th standard physics class. Today we are going to see about the unit 1 measurement. In the last class I explained about this vernier caliper, one of the measuring instrument. Today class I am going to explain about the other measuring instrument, what is called as a screw gauge. Vernier caliper is used to measure the diameter of length and breadth, height of the object. But the screw gauge can be used to measure very thin object. It may be wire or any sheet, paper. Thin dimension we can measure by using the screw gauge. Let us see the description of the screw gauge. In the screw gauge, it has a U-shaped metal frame. In this metal frame, one end is some projection is given on the left side of the metal frame, that is called as a anvil. Opposite to this anvil, there will be some projection very lengthier, that is named as a spindle. And this U-shaped metal frame is attached with a metallic cylinder. In the metallic cylinder, some measurement is given on this side, and that measurement is given in the millimeter, and this is called as a barrel. And over the cylinder there will be some rotating part will be given. This part can be rotated and move over the cylinder. This is named as a thimble. And this head, this what is called as a head of the cylinder. And this head of the cylinder, some measurement is given. That measurement is divisions given in the form of division. Over that there will be 100 division will be given. And the rotation can be stopped by the help of the ratchet at the end of this head. This measurement, you see this, the cylinder, that readings is called as a scale, is named as a pitch scale. And the measurement over the head, what is called as a head scale. There will be two scale is given on this screw gauge. One scale is a pitch scale, another scale is a head scale. The head scale is moved over the pitch scale. The pitch scale is fixed, but this is movable. Can move towards and we can bring it at the backwards. And this screw gauge is a very important for all the measurements. Very thin objects, this dimension can be measured with the help of this screw gauge. So what is the least measurement from this screw gauge is that count, what we called as a least count. That is the least distance we can measure by using this screw gauge. Least count is always calculated by the the value of one division in the pitch scale divided by total number of division on the head scale. The value of one division in the pitch scale. What is the value of one division? That pitch scale value we can calculate it by how many rotations we are given on the head, by which how many division here moved. If you give one rotation, one division is moved here. That means the value of one division in the pitch scale is 1 millimeter. one division value is 1 millimeter. And total number of division on the head scale is 100. So I already told you there will be 100 lines or drawn over the head. So 1 by 100. And divide by 1 by 100, we are getting 0.01 millimeter. So this is the least count of the screw gauge. So we can measure the dimension thickness of the wire up to 0.01 millimeter. But ordinary scale we can measure only the 0.1 centimeter. Vernier caliper we can measure 0.01 centimeter, but screw gauge we can measure 0.01 millimeter. So that is the difference between the measurements on these instruments. So how do you measure the thickness by using this screw gauge? Let us see this usage of screw gauge. Usage. How can we use it? Before using the screw gauge, we have to find out the zero error. Zero error, because all the instrument has some error in manufacturing. So that error we have to rectify it. So first you have to find out the zero error. Zero error have two types. I have three types I already told you. No zero error, positive error, negative error. Negative error. Let us see this no error. When we have, before keeping any objects, usually object is kept between the anvil and the spindle in the screw gauge. Before we keeping the object here, we have to find out the zero error. So how do you find out the zero error? See here in this. This is a pitch scale and this is a head scale. The pitch scale, the measurement is given on the pitch scale axis. So this axis, some measurement is given like this. The head scale division will be given like this. This axis what is called as a pitch scale axis. Pitch scale axis. When the pitch scale axis is coinciding with the zero of the head scale, if there is coinciding with this, we get no error. So when you rotate the rod shuts on the side, when you rotate the rod shut, when you're rotating this before we keeping the objects, so when the reference line, that is axis of the pitch scale, is exactly coinciding with the zero of the head scale, then there is no zero error. The instrument is very accurate. But this is not happen. Usually some error will be present in the screw gauge. Let's see, how do you calculate the positive error? Some of the instrument has positive error. So how do you know that positive error is? If this is a pitch scale and this is the axis of the pitch scale, the measurement will be given in millimeter, and this is the head scale. You see here, if this zero of the head scale zero is below the pitch scale axis, if the zero is exactly coinciding the previous case, but in this instrument, zero of the head scale is below the pitch scale axis. if the 0 is below the pitch scale axis, below 0 is below the pitch scale axis, then the error is called as a positive error. So how much this positive error? How do you calculate this 0 error? In this case means how many division it is below. So what is the division here coincide? That is fifth division is coinciding. You take this fifth division and multiply it by the least count of this instrument, that is 0.01, that we multiplied. This error is positive, so put plus, then plus 0.05 millimeter. So the error of this instrument is 0.05 millimeter. Then we have to correct this error. That error is called error is corrected. That correction is called zero correction. The error is positive. Then we put minus 0.05 millimeter. So what is the value we are arrived? That value we have to subtract 0.05 millimeter. So that correction is called as a positive zero correction. So let us go for this negative error. Some of the instrument we have the negative error. So how do you calculate this negative error? How it will happen in this instrument? You see here, it will be like this. This is a reference line, pitch scale axis. You see here, 0 of the head scale is above the pitch scale axis. So if the 0 is above, then the error is called negative error. Then how do you calculate this negative error is, 0 error is, that we have the special formula, that minus, because the error is negative, so we have to introduce in the formula as negative, then 100 minus n, that should be multiplied by the least count. That means minus 100, which division this axis is coinciding, 95. So 95, in the n place I substitute the coinciding value. If the error is negative, 95, and the least count is 0.01. So minus, and you subtract this from 100, we get only 5. 5 into 0.01. So minus 0.05 millimeter. So this is a zero error in the case of a negative error instrument. How do you rectify this error? So we put the opposite sign, plus 0.05 millimeter. So we have to add 0.05 millimeter in the original value. The error will be rectified. So this is the way. These are the three types of error that will be occurring in this screw gauge. Thank you.